assessment asks us to predict a structure for this NMR spectrum. Doing so from the beginning with all of the steps involved would probably make this about a 15-minute video. So in the interest of time, I've actually already done a lot of the work. If you're confused about what I'm going to talk about here, I encourage you to go back to that section of the book, talk with your instructor to get some more information on how to do these steps, but I'm going to cover the highlights here. The first thing we want to do is look at our molecular formula and calculate the index of hydrogen deficiency. For this molecule, it's 0. That means no pi bonds and no rings. I have labeled each of the signals, and I have built a puzzle piece corresponding to each of those signals. Looking at the chemical shift, the integration, and the multiplicity allows me to build a puzzle piece for each signal. Chemical shift of 3.5 with an integration of 2 and a triplet, meaning it has 2 neighbors, gives me a puzzle piece like this. 2 hydrogens next to a halogen, that's the 3.5. The 2 hydrogens are the integration, and it's next to 2 hydrogens, that's the neighboring hydrogens. I have underlined the 2 hydrogens that results from the integration and not underlined the ones that result from the multiplicity. I'll talk about that in a second. For signal B, that's at chemical shift 1.7, it has an integration of 2 hydrogens. Again, I've underlined those. And it's a quintet, which means it has 4 neighbors. You can't have 4 hydrogens around 1 carbon, so those 4 neighbors are split between 2 carbons on either side of the observed hydrogen. Signal C has a chemical shift of about 1.5, and it has an integration of 2 hydrogens. Those are the underlined ones. A sextet means that it has 5 neighbors, and so those 5 neighbors are split 3 on one side and 2 on the other. The last signal has a chemical shift of 0.9. It has an integration of 3 hydrogens that are underlined, and a triplet means it has 2 neighbors. The last thing to point out is these boxes are just placeholders to remind me that these carbons still have 1 more valence to fill. I'm only making 3 bonds on each of these carbons, and so those boxes remind me that when I build the structure, I still need 1 more bond to each of those carbons. Now that I have underlined the hydrogens and the puzzle pieces that correspond with each of these signals, I'm ready to start building this and putting it together into a final structure. When I do that, I like to start with something that I know is going to be on the end of a molecule. Looking at this underlined CH3, these 3 hydrogens cause signal D to appear, and these 3 hydrogens are going to have to be on the end of a molecule. So I might start with signal D, which is a CH3 next to a CH2. The underlined CH3 is the hydrogens that cause signal D, and the 2 hydrogens are the neighboring hydrogens that we get from the splitting pattern. What this means is if I have a signal that has a 3 hydrogen signal next to a 2 hydrogen neighbor, that means I better have some other signal that's a 2 hydrogen signal with 3 hydrogens as a neighbor. I only have one of those, and that's signal C. That's a 2 hydrogen signal with 3 hydrogens as a neighbor. This tells me that D and C likely overlap. I'm looking for overlap between underlined hydrogens from one signal and non-underlined hydrogens from another signal. And I'm going to do that throughout the entire structure. This allows me to overlap puzzle piece D with puzzle piece C, and I still have another CH2 group over here that I could use to overlap another puzzle piece. Right now, I have a known CH2 group next to a neighboring CH2 group, so I'd better have some other puzzle piece that's a known CH2 group next to a neighboring CH2 group. That would be puzzle piece B. I have a CH2 group next to a CH2 group, so I can use puzzle piece B to overlap with puzzle piece C. These CH2 groups, 1 underlined, 1 not underlined, and these CH2 groups, 1 underlined, 1 not underlined. That still has 1 more CH2 group and an open valence, so I need 1 more puzzle piece that's a CH2 group next to a CH2 group. That would be puzzle piece A. Puzzle piece A has a known CH2 group next to a neighboring CH2 group, so I can use that puzzle piece down here to overlap the underlined and the non-underlined hydrogens. This brings along the chlorine, and chlorine has no more valences, so this could be the end of the structure. Using this allows me to see how all of the hydrogens line up in the entire structure and allows me to build the entire structure. When I add all 4 of these puzzle pieces together, I get a final structure that looks like this. If you wanted to, you could redraw that in a line angle form for your final structure, and that would be chlorobutane. Chlorobutane is the structure that corresponds to this NMR spectrum.